This is Miss Martin, and this is the comparison of mass and weight for science class. So basically, when you're looking at mass and weight, you want to compare how they're alike and how they're different so that you have a better understanding of these terms. So at the bottom here, I've piled up a whole bunch of information, and I'm going to pull it out and talk about each thing as I pull it out. So the first thing here is we have mass, we have weight, and we have a couple of pictures of some anvils to kind of give you an idea what that looks like. So here I pull this one up. Mass is a measure of how many atoms are present. Now, kind of to give you, let's delete that there. To kind of give you a picture of that, that would be if you were to take, here we go. If you were to take a look at this, it would be kind of like if they're just basically here, the little atoms that are in the anvil, and a mass is just kind of a count of those atoms. All right. Now, weight is the measure of gravity that pulls on those atoms. So when you're looking at weight, those little atoms are still present. They're still there. They're still part of the deal. But weight is actually about the pull of gravity on those atoms. So weight is actually more of the measure of the arrows here that are pulling down on each atom. So weight is more about the pull of gravity than it is about the actual atoms. As you can see, Newton is the standard unit for weight, and grams and kilograms are the standard unit for mass. Weight can change if gravity changes. So here, if these arrows were to get bigger because there's more pull, so if this arrow got bigger because we had a stronger pull of gravity, then the weight would get bigger. If the gravity got less and the arrows got smaller, then the weight would be less. Whereas over here, inertia is what's connected to mass. Inertia is more of the measure of how mass and movement interact. It's a property of matter that based on a tendency to not change. So a mass is, if it has a big mass, then it's hard to get moving. If it's a small mass, it's easier to get moving. And if it is moving, it's harder to stop. The tool used to measure mass is a balance. Now, a balance, it compares masses. So you have two things on it, the thing you're measuring and then the other things that you're comparing it to. So a balance wobbles back and forth, and that's how it works. Now, a weight is measured with a scale. And a scale is a tool that has springs that flex with gravity. So it actually is measuring the pull as opposed to the actual amount of atoms. If there's more atoms, then there's going to be more pull. So if you have more mass, you're also going to have more weight, because that's how, as long as you're in the same environment, you have the same gravity. So if you have more mass, you'll get more weight because of the gravity. Mass only changes when you change the amount of matter that you have. So if you break it and throw half away, you've changed the amount of matter, so you've changed the mass. If you eat, then you are putting matter into your body, and that's how you gain mass. You have more atoms in your body. It doesn't change when gravity changes. So if I take this weight to the moon, it's going to have the same mass, because mass only changes when you change the amount, not when you change gravity. Now, weight depends on gravity. So if you can change the gravity if you change the weight. Or you can't, if you change the gravity, the weight will change. Gravity changes if there's more distance between objects, kind of like a magnet. So the weight gets less the further apart objects are. Usually in class, when you're talking about weight, one of the objects is Earth. And it's really huge, and that's what creates most of the weight that we talk about. But the sun has gravity, so it creates weight. Jupiter has gravity, it creates weight. Basically, anything really massive has a way to produce gravity, and so it produces weight. But every single atom has a trace amount of gravity. So even things like a ballpoint pen can create weight in other objects. The problem is that it's so infinitesimally tiny that nobody measures it or cares about it. Here's where things go astray. Both mass and weight get mistakenly interchanged a lot. People generally don't leave the Earth. In fact, only about 600 people total in the history of the planet have left Earth. So weight doesn't change in regular people's day-to-day life. So they don't worry about it. So they use the word weight when they really mean mass. They use the word mass when they really mean weight. And it doesn't usually matter because nobody's leaving the planet. Both of them depend on atoms. Weight depends on gravity's pull on the atoms. Mass is just how many atoms there are, but they both depend on atoms. And lastly, the main reason they both get confused is that a scale, the tool that typically gets used for weight, can be calibrated to ignore the force of gravity, since it doesn't change because the scale's not likely to actually leave planet Earth. So sometimes we'll use a scale for mass even though it's the wrong tool because they're faster and easier. So this is the key differences between mass and weight. I hope that it's helpful to you.